Lesson 18 through 20, inequalities in one variable. So just a little review. The inequality sign means that tells you which value is bigger. So it's sometimes we draw a little alligator teeth on it, showing the alligator opening its mouth towards the bigger quantity. So this is a true inequality. 4 is greater than 3. And 5 is less than 8. So again, the alligator mouth opens to the bigger quantity. And then this sign means greater than or equal to. So let's graph a few of these on a number line. So we're going to make a simple number line here. And this inequality tells us that x, our variable, is greater than 2. So that means x could be 3 or 4, 5 or 3.5 or 2.5 or 2 3/4. It could be any number that is greater than 2, but not 2 itself. So we're going to draw an empty circle around 2, and then we're going to draw a little line like this to indicate that x is all values that are greater than 2. Let's do this one now. So here is n is less than -3. And we'll also do an open circle. And it's all the values less. So we're going to draw an arrow going this way to indicate it's all those values less than -3. Now here's one with a greater than or equal to sign. So in this case, b is greater than or equal to 1. We're actually going to do a filled in circle because b can be 1. Or it could be any of the quantities greater than 1. You're going to do your own here, so pause the video and try this on your own. We don't have to label all the points. We could just do something simple like that. H is less than or equal to, so filled in circle, less than or equal to 4. Now this one has the x on the other side. When you're reading an inequality, you should always read it out loud or in your mind from the perspective of the variable. So I would say here, x is less than 5. It's mathematically correct to say 5 is greater than x, but it's going to make more sense for us in terms of doing the graph if we read it from the perspective of a variable. We could also rewrite it like this, x is less than 5. That's the same inequality. So I'm going to make our little number line. It's going to be an open circle because it's less than, and it's going to be there. Okay, let's see what happens when we do operations, addition, subtraction, multiplication, division with inequalities. So we're going to start with this inequality. 1 is less than 2. That's a true inequality. And we're going to try a number of different operations and see if what we come up with is still a true inequality, if the inequality still makes sense. So in this one, we're going to add 2 to each side. So if you add the same thing to both sides of an inequality, this new inequality then is 3 is less than 4. Is this new inequality still true? Yes, 3 is less than 4. All right, let's try this. Subtract 5. So this would be -4 is less than -3. And I put a little number line up here for reference. So -4 is less than -3, right? It's farther down in the negative direction. -4 degrees of temperature would be colder than -3 degrees. Still true. All right, so subtracting the same thing from both sides, the inequality is still true. What if we multiply both sides by 3? We get 3 is less than 6. Yes, that is true. What if we divide both sides by 2? Is 1/2 less than 1? Yes, it is. What if we multiply both sides by -1? Is -1 less than -2? Let's look at our number line up here. Here's -1. -1 is not less than -2. -1 is actually bigger than -2. No, that is not true. What about this? What if we divide both sides by -1? Then we get -1 is less than -2. We get that same thing again. And that's not true. To make that true, we would have to change the direction of the inequality sign. We'd have to say -1 is greater than -2. So that's what we're going to need to do when we're working with inequalities. We're going to have to flip the inequality sign, change the direction of it when we either multiply or divide by a negative number. So we're going to remember that when we're doing these problems on the next slide. So here we're going to solve inequalities. And we're going to graph the solutions on a number line. Solving an inequality is just like solving an equation. You just treat the inequality just like an equation. The only difference is if you have to divide or multiply by a negative number, you have to change the direction. So, just like when we solve equations, we are going to simplify both sides of the equation before we do anything. This side is as simple as it gets. And then we ask ourselves, can I combine any like terms here? Yes, I can. Those are like terms. -5n plus 2n is -3n. Just like in solving an equation now, we have to get the variable by itself. So we're going to divide both sides by -3. And then we get n on this side. Now we've divided by a negative number. Remember, that means we have to change the direction of our inequality. So here is our inequality. N is less than -1. Remember, I'm reading from the perspective of the variable. I could also rewrite it like this. N is less than -1. And I'm going to draw a graph. Got 0, and I got -1. We're going to do an open circle, because it's not equal to, it's just less than. N is less, and then we're going to put our arrow this way. N is everything less than -1. And then I can use a test point to check my solution. So plugging in 0 is always the easiest. It's always easy to plug in 0. If I plug in 0 here to my original inequality, it should not be true because 0 is not part of our solutions, right? 0 is not in the shaded area. So let's see. If I plug that in, I get 3 is less than 0, which is not true. Okay, so good. 0 we shaded the right direction. 0 should not be part of the solution. All right, let's try this one. We're going to, again, combine like terms. That'll give us 12x plus 2 is less than 14. We have to get x by itself. So we're going to subtract 2 from both sides. We're going to get, that'll give us 12x is less than 12. And then we got to get x by itself. So we're going to divide both sides by 12. And we're not going to flip the inequality this time because we divided by a positive number. So we get x is less than 1. It's going to be an open circle. Okay, and then we're going to use our test point. We're going to try 0 again. And this time, plugging in 0 to our original equation should make the inequality true because it's part of our solution. It's in the shaded side. So let's see. 6 times 0 plus 2 plus 6 times 0. Is that, question mark, less than 14? 0 plus 2 plus 0 is less than 14. 2 is less than 14. So we've shaded in the right direction. Okay, so you are going to solve the other ones on your own. I'm going to do one more demonstrated and then you solve the other ones on your own for homework. Let's do number 4. Here we have to simplify both sides of the equation before we move anything around. And by order of operations, we got to multiply before we do any adding or subtracting. Actually, we'd have to, if we think of order of operations, PEMDAS, right? Parentheses, exponents. We'd have to do the parentheses first, but there's nothing to do in the parentheses. Those are not like terms. That's as simple as it gets. So no parentheses, there's no exponents. So now we're going to do multiplication. Okay, so -3, we're going to leave that by itself. We're not ready yet. We're going to do the multiplication. Then we're going to multiply -6 times 4x is -24x. Negative 6 times 6, whoops, to mind our minus 36, is greater than negative 111. Okay, combining like terms, so I'm going to combine my integers. I get negative 39 minus 24x, that's a negative 111, add 39 to both sides, 24x greater than negative 72. Divide both sides by negative 24. Now we've divided by a negative, so that means we have to switch the direction of the inequality. There it is. I'm going to do my graph. X is less than 3. Okay, so if I do the test point of 0 and plug it in, that should make my original inequality true because it's in my shaded area. So let's try that. Negative 3 minus 6. 4 times 0 plus 6 greater than negative 111. Okay. Negative 3. I'm going to have to simplify inside the parentheses. Negative 3 minus 36, and we get negative 39 is greater than 111. Yes, that's true. So I've shaded the right area. All right, you for homework are going to solve the rest of these. I'm going to actually give you the answer. To get credit, though, you have to show work how you get the answer. So this is the answer to this one. This is the answer to this one, and this is the answer to this one. So, show your work on all of these to get to those answers and then graph your solution.